In today's video, we're going to build our jump and fall states, as well as some variable height code into our jump, and we'll add these little fun indicators that you see here that we use for troubleshooting. So in today's video, what we're going to be doing is we're going to, of course, build these, the two states that we need for our platforming, or at least the basic ones, right? And so that's jump and fall. And now you could build these as one state, just a jump state. I like to split it up, and it adds a little bit of complication, but it also adds a little bit of easily controlled variation between the two. And so, you know, pick your poison. You don't have to do exactly how I do it. And actually, on that note, before we get into my implementation, I want to look at some of the people who submitted some of their solutions for this, because this was the homework assignment I extended at the end of the last video. So I've just selected two that we'll look at real quick, and then we'll get on to the tutorial. All right, so this first solution is submitted by Pigeon. That's what they go by on Discord anyways. And let's go ahead and just run this real quick. It's kind of funny to see a project that's like, hey, that looks like mine. You can see we've got a jump and a fall state, and it doesn't have variable height yet hooked in, I don't believe, but it's like a timer-based jump, and so he determined the jump based on a timer, which is a pretty good solution. And we can go ahead and glance at a little bit of the code real quick, but you can see that he set up jump and fall states. So if you look, for example, at the idle, let's see what he's done here. He's got... here we go. In his process, he checks for is action pressed jump, and he returns the jump state. So then we could look at the jump state. And in here, he creates a timer in his enter function. And then he sets some of the variables on the timer. One shot, meaning it'll just play once and then end, and set the duration of that timer before it times out. Here he's adding in the timer to the scene tree. Okay, so this is a pretty good way of doing it. You know, I'm not going to do it this way, but this is fine. If it works for you, it works. Of course, you may want to adopt what I do as well, but this is great. I like how you've instantly caught on to using the enter function for setting up the things that you need to in your jump state, and then you start the timer. And then during the process of the jump state, you've got some velocity, jump velocity happening, and you're like doing basically negative gravity here, which is a nice, interesting solution. And, you know, you're multiplying it by a flat variable. I would probably recommend exporting this so that you could tweak it, making that an export variable. But, you know, we'll do that. And then, of course, you've got player movement while you're in the air by using the player direction. This is all great. Wonderful. Good job. You've got a way to get into the fall state by using this timer timeout function, right? So I guess I skipped over that. But here you connected this timer. And actually, you know what? You don't have to quite write it like this. This is fine. This is a great implementation. I think the reason you wrote it this way is because you were maybe struggling with getting the ability to pass in that duration. So what I mean is let's go ahead and comment this out. If you're connecting a callable to one of these signals and you need to pass in a variable, it can get a little bit tricky. But in general, to connect to this signal, right, it would just be like duration timer dot timeout dot connect, which is what you wrote. And then you passed in that little like lambda function statement. Really what you want ultimately, right, is to call this on duration timer timeout, but you need to provide the argument, which is the timer itself. So I'm going to go ahead and just paste this in here. So the alternative solution that I would have used is in here, in your connect statement, after your callable, you can type in .bind, and then bind is going to allow you to include the arguments that you need. So in this case, it's the duration timer, right? There we go. Okay, so that should work just as well. And so let's go ahead and run this and see if it does work. Yeah, still working. Pretty cool. So there you go. There's an alternative way to do that. Thank you, Pigeon, for submitting your homework and your solution, and keep up the good work, because this is the kind of stuff that's going to help you grow and advance quickly as a game developer. Now, another solution that was submitted is this one here, and this is James Nye. He's been a long-time follower and supporter of the channel. I thought it was fun to show his. He implemented a variable jump height and things like that, and it's looking really slick. Now, he didn't provide source code, and that's okay. We don't need to provide source code or anything like that, but that's one reason why I'm not going to show you his code. But looks like a great implementation, so thank you, James, and thank you for sharing. Okay, so now that we've done that, let's get into how we're going to implement this here. And for those of you who aren't submitting homework, I don't want you to feel bad or anything. This is just a fun thing that I tried, And I'm really excited with the response in my Discord server and in that community that people are excited about the homework. I do, however, suggest that you do something on your own, right? Even if you don't feel like you want to submit your homework, do try the exercises, because it is going to help you learn a lot. As you bang your head against the wall and make mistakes, you're going to learn more from your mistakes sometimes than from what I teach you, you know? And so with that said, let's get into this. Let's go ahead and create the two new states that we're going to need here. We're going to have a jump and a fall state in our state machine. And the reason I'm separating these is so our jump state is going to handle when we're moving up through the air, and our fall state will handle when we are falling down. And this means if we walk off of a ledge, for example, we don't have to enter a jump state or some other state to get him to fall. We can just use the built-in fall state. And then that gives us clarity on what's going to happen when we walk off the ledge, right? Otherwise, you have to decide, okay, do I enter the jump state, but do I cancel the jump velocity? Or, you know, you have to make decisions like that. And I think having a fall state at least cleans up some of that decision making. And like I mentioned, it does come with some bloat, right? We've got extra states, but when we're building our player character, I don't really see too much of an issue on this. If anything's going to be slightly over-engineered, then maybe the player's the place to do it. And I guess I should use that term carefully. Over-engineered could be dangerous. But what we want to do is make sure that since this is a playable character and he's supposed to function in a very specific way, we want to make sure that we build him thoughtfully and take into account some of the things that we might encounter down the road. Okay, so 2 new child nodes. We're going to make, I'll just go ahead and duplicate that. Control D is a shortcut there. First node we'll call jump, and the second node we can call fall. And of course, we're going to need state scripts to attach to these, otherwise they're not going to do anything. So we're going to come down here. I already have my states folder open, but if you don't, go ahead and do that. And you know, I'm going to duplicate one of these scripts. I kind of hate doing this because sometimes it'll cause like a compiler error because the new script will have the same class name assigned, and that's going to cause an issue, right? But we'll rectify that pretty quickly. So this will be jump. And I'm going to do that one more time, and this will be called fall. And then right away, we're going to open both of these up. So before we put them on here, let's open jump and fall. And so you can see the class name is player state idle on both of these. We want to change it. So this should become fall, right? I'm on the fall script, and then let's find our jump script, and this should be jump. And then now if we save that, that'll hopefully clear up some of any of the issues that we might have had. And you can see I've got some other scripts already open. I'm just going to organize these close to each other. Fall, jump, yada, yada, yada. Not much is happening in these. They've got the code that we wrote in our idle state, but that's okay because we'll replace it. Now that we've got these set up though, let's go ahead and attach each of them to our states, to the nodes, and just double check, make sure we've got the correct script assigned to the correct node, and we're good to go. Now, one last thing that we'll do as we're just setting up these nodes is let's go into our root player state script. And, you know, this is something I almost consider doing. There's a new feature in Godot 4.5 where you can create abstract classes. And this is almost an abstract class. And an abstract class is a class that's not meant to be instantiated or assigned directly, but it's specifically for defining a class that's going to act as a template, which is exactly what we've done here. Now, I haven't tested this, and the reason I didn't switch it over to an abstract class is because I think some of the assignments and the variables and like these state references that we're doing, I don't think we can do that in an abstract class. And so for that reason, I'm keeping it as is. Now, I'm going to go ahead and just grab both the jump and fall states, drag and hold Control or Command, and drop them in. There we go. So now we've got references to our new states, and we'll have easy access to them. Oh, except I forgot one thing, didn't I? You'll notice the difference in the node paths here. So let's fix that. Let's go ahead and right click on these and say access as unique name. And then if we do it again, boom. Okay, there we go. That looks better. That's not going to change anything functionality. Just a reminder, the reason for this access by unique name is that if I were to change the name of this node here, it would still function because it would still be able to find them, because changing the name of a node would change the path, and we're coding a path in there, which is a little bit accident and danger prone. Using these names is not so prone to issue. Of course, it means they have to be the only node with that name in your scene tree, but that's okay because they will be. Now, I think the most obvious thing we could do right here is let's first start by hooking up our jump state and working with that. And before we're going to write any code in the jump state, I do want to come into my idle state And I just want a code in here so that we can enter the jump state. Okay, that's going to make testing our code a lot easier. Now, one thing that I saw that was really commonly done by others was that they did their input detection in like the process or the physics process loop. And honestly, I don't really see a huge problem with that personally, and I've done that a lot in the past, but I am going to try and keep it a little bit more organized in the sense that I want to do my input detection as much as possible here within the handle input. So what we're going to do is here in handle input, we're going to do an if check, and we're just going to see if our event dot is action pressed. Okay, there's a couple of those, right? I'm just going to review that real quick. There's action pressed, action released. There's is action type. Okay, I don't know a whole lot about a couple of those, but we could learn about it pretty easily with the documentation, I think. Pressed is the one we want. And in here, we need to provide the name of the action. And so we've already set those up. We've got a jump action. Okay, so that's the action that we're going to be listening for here. You need a colon after that if statement line and then an indented piece of code. Otherwise, we're going to have an error. And so all we're going to do here is if jump is pressed, we're going to return the jump state. Just like that. Really simple and really straightforward. Now with just that, we should be able to enter the jump state. Nothing's going to happen, but we should see the label change to jump. And there we go. And I can run again. That's nice because because our jump code currently is the same as our idle code. So we've got to wait to get to the run state. Let's go ahead and delete this now that we're in our jump code, and we're going to change how we handle things here. Okay. One thing that I mentioned as we looked at Pigeon's code is he had used a method where he did a negative half of the gravity for his jump, and he also used a timer. What we're going to do with our jump, we're not going to make it timer based, we're going to make it velocity based, and we're going to export that variable on our jump state. This way, if we need to find variables that are related directly to the jump, we just come straight to this state and we can find it. And so let's start with an export variable, and we'll call this variable jump velocity. And it's a float, and I'm going to set it by default equal to, I happen to know a value that I kind of want, 450, okay? You don't need the 0.0, but it looks fancy, so I'm being a fancy boy. So now we've got an export variable. Let's go ahead and save that, and you'll see now when we select jump, we've got a jump velocity here, right? So you could change this, and you could reset it to your default if needed, and this is going to allow for easy iteration as you're testing your game. The next thing that we can look at here, we don't really need our init function, so I'm just going to ignore that for now, but enter, obviously we've got that comment that we made because we copied it over. It says play animation. We don't have an animation to play yet, so that'll be, in a subsequent episode here coming up. But really all we need to do is just add the velocity to our player to get him to move. Here's how I'm going to do my enter. It's going to be player.velocity.y, and then we're going to do minus equals jump velocity. Okay, so what that's going to do is it's going to take whatever his current velocity is, subtract this number from it, and that will be our new y velocity. Let's go ahead and see what that does, just with that little bit of code. Boing! Pretty nice. Now the problem is we're stuck in the jump state. If I'm running, oh no, I can't get out of jump state anymore, I remove that code. So let's get away for this to work full circle. And so what we're going to do is we're going to be jumping between states here just a little bit just to get things to work. So now that we see that jump velocity is working, and I'll test that one more time, you can see that we've got a velocity and it works really nicely, right? It's just like an impulse. We just added a force, boom, and then that gravity that we already have built in to our player script is going to slowly reduce that, right? Because we have in our physics process here, we're just doing this little gravity calculation. Okay, that's going to take care of everything we need to get him to fall back down. But let's go ahead and have a way for us to enter the fall state. And the first way that we can enter a fall state will be from the jump state. So if we're jumping and we hit the apex of our jump, as soon as we start to fall down, we want to enter the fall state, right? So let's go down to our physics process, because this is where we're going to be seeing that change in velocity happening. And we'll do a check. So if player.velocity.y is greater than or equal to 0, because a positive number in our y velocity is downwards. So if it's greater than or equal to 0, that means we're no longer moving up. We've either apexed or we've started to fall. So we can return the fall state here. I'm going to add one additional check. And this is going to be specifically used in our fall state, but I think there might be a potential, maybe not, but I think there's a potential that we hit the ground and we maybe should end the jump instead of fall, right? Like we maybe jump just perfectly onto a ledge. So just to be safe, This is probably not needed. I'm going to say if player dot is on floor. Okay, that's something we can check. Isn't that nice that our character body node has that built in? So if the player is on floor, then we know we should return the idle state. Okay, just like that. And since I've got this check here, I'm going to make this an elif. Okay, now this is kind of cool because this is a pretty minimal amount of work to do. We've just got two simple conditions to return these states. So by doing this, we should enter the false state. Yeah, there we go. Of course, our false state now doesn't do anything, but we'll get to that in just a second. Okay, so I guess let's get into that then, the false state. So let's go ahead and find our false state over here. I mean, you can find it here. I just find that using the nodes and clicking on the script is a convenient way to find them. Now, all we really need to do right now in our false state is we need to clean up some of this stuff, right? We don't need that. We don't need our player velocity equaling 0. But we do want to do a check, just like we did in our jump state, where we're checking to see if we're on the floor. Let's go ahead and copy that little if statement, and we'll put that in our false state, right? So this is where you can see having these multiple states, we've got redundant code. I'm not going to worry much about it. You can disagree in the comments maybe if you like, and I may listen. Let's see. So if our player is on the floor, then we'll return the idle state. And for now, I guess that's all we're going to do. So let's just test this. So now we should be able to do full circle, like jump, fall, and idle. Jump, fall, idle. Very good. Now we can't jump while we're running, and we can't move while we're jumping, and our jump is not variable height, right? So now that we've got these hooked up, let's just go through and let's add a few additional things so that this is a little bit more complete, and then we'll just continue to refine. So what I want to do right now, I think, is go to the run state, and we're going to make it so we can jump while we're running. So really what we need to do here, actually, let's go to our idle state, and let's just copy this. If event is action pressed, let's go back to run. Bada bing, bada boom. Okay, I'm going to remove this comment. It really doesn't mean anything. Okay, so there we go. If action is action pressed, jump, return jump. So now we should be able to jump while we're running. Voila. And what's interesting is, as you can see, I've got a velocity built in when I do it that way. We want to be able to control our jump while we're in the air. Like if I jump while I'm idle, I can't hit an arrow to move, or vice versa. If I'm running and I can't stop. You've played old games like this maybe where you're like, if you're running and you jump, then you have a very fixed jump and you have to just know exactly where to jump to land. And that can be like really frustrating. Maybe that's part of the challenge and maybe you want that, but we're going to make it so that we can move while we're in the air. Okay, now a little forward before we do this, we're going to go over to our jump state. There is a possibility that you want your movement to feel different while you're jumping than while you're running. And by movement, I mean your horizontal left and right movement. For the sake of this game and wanting to keep that snappy responsiveness and the kind of intuitive controls, I want to use the same movement that we're using in our run state. So like if we look at our player script, we had kind of planned on doing this and we had exported this move speed variable in the player because we're going to be using this move speed across multiple states, okay? But again, you don't have to. And I've certainly done this in the past where you have a different move speed per state, and that's perfectly fine. It just really depends on the goal of your game and how you want the movement to work. So, worst case, you could add a custom move speed to your jump, and you could try it out and see what you like. And then if it ends up being the same, then so be it. It's not really going to hurt that much. It just is nice to have one spot to adjust that. But really all we need to do is come in here into our jump state, and in our physics process, after we've done our checks here, we just need to do some basic code, just like we've done in our run state. And in fact, it'll basically be identical, but it's going to be player.velocity.x equals. So what we did before is just get our player direction. And I guess we need the x component only because that's what we're doing here. And then multiply this by the player move speed. There we go. And before we test this, I'm going to go ahead and copy that. And I'm just going to put this in my false state in the physics process as well, because we want it to happen the same in both. Okay, so there we go. Now I can move in the air. And if I am idle when I jump, I can still move. Okay. Feels pretty good, pretty smooth. Really basic amount of code needed to implement this. Okay. The next thing that we want to do to make this player controller feel better is probably the variable height jump. But before we do that, I want to do something fun. We're going to build in some little kind of debugging display so that we can have a better visual of what's happening as we play with and test our jump code. Okay, so what I'm going to do here, and I guess I should say this is kind of optional, so you don't have to do this. So if you want to skip ahead, you can, and you'll see what I'm doing. But I figure a lot of you might want to do this, and you'll learn from this as well, especially if you're new to Godot. So I'm going to just add a node 2D as a child of my player, and I'm going to give it a name of, it's going to be a long name. We'll call it the debug jump indicator. Okay, and then I'm going to add 2 sprite nodes as a child of this. Sprite. Oh, sprite. Hey, I got a sprite for my node here. Oh man, that was terrible. That was a really terrible accent. Don't ever do that. Okay, let's see. Let's just go ahead and we'll just use gradient texture 2D for these. And let's see, open that. Come down here to fill. This first one, we're going to make a small circle. So I'm going to change this to radial. And we're going to go from 0.5 to 0.5. Or from 0.5, 0.5 to 1, 0.5. And we're going to change this to be a teensy tiny little texture. And it's not going to look too much like a circle because it's so small, but let's change our gradient stops. We're going to have white. And then we're going to have transparent white on the right-hand side. And then I'm just going to drag this out so that we have a bit. You can see it looks like a square because it's such a low-res texture. And honestly, it's probably fine if it's a square, whatever. You know what, though? Let's make it a little bit bigger. I want it to be like 1, 2. I want it to be an odd number. Let's make it 5. 5 pixels by 5 pixels. Oh, nice. Nice. Okay. I like that little circle there. So we're going to go ahead and keep that. Save this. And on this other texture, we're also going to use a gradient texture 2D. Just because it's a simple way to just get a white texture. I wish there was a solid color texture. I don't think there is. If there is and I'm stupid, let me know. I mean, there was something obvious I didn't know, which was grouping and locking, which is like right here or right here, because these were features that didn't exist in version 3 of Godot. And I wanted them back then and they added them and I didn't even notice them. So it's like, what the heck, dude? But okay, here we go. So let's make the width of this something like 12 and the height is just 1 pixel. So we've got a line, and I'm going to come down below and under visibility, this self-modulate, I'm going to change this to a semi-transparent. I'm just going to drag the alpha down like that. We're going to leave them white. We're going to display these in the scene. If we go ahead and run, you'll see that this is just going to be stuck to our feet. But what we're going to do is we're going to add this little indicator whenever we jump, hit the apex, and land. And it's going to help us visualize what's happening with our jump script, okay? And it's going to be really most important and useful for demonstrating the coyote time, I think. But here we go. I'm going to go ahead and now that I've created this node, I'm just going to go right-click on it and go down to Save Branch as Scene. And because we're in our player, it should automatically put you in the player folder. But if not, you're going to want to navigate there and just go ahead and save it. And once we've done that, you can see this is now a scene. Like we could open it and it's its own little guy here. Just like that. And we can delete it now. We don't need it here because we're going to be instantiating this scene dynamically. So let's add some script to our player to be able to do this. In order to be able to instantiate it though, we do need to get a reference to the scene, and I'm not going to create a code region for this. This is kind of temporary, but what we're going to do is at the top of our script, we're going to find this debug jump indicator scene. We're going to drag and hold Control and drop it in. And there we go. You can see it created a constant variable, which is a preload of the scene with this UID. UIDs are newer in later versions of Godot. If you don't have one of the later versions, if you're on just like 4.2 or something, then you probably don't have the UID. That's okay. It'll be the scene path and both will work just fine. What the UID does is it means like if we move this around or even rename the file, I think it should still find the file, which is nice. Okay. It's kind of like accessing by unique name for an item in the scene tree, except looking in your project, it's saying, hey, give all my files an ID, and then I just want to access it by that ID. But we can now use this variable to reference that scene, and what we're going to do is we're going to use it to load instances of that scene, okay? So we'll create a simple little function to allow us to do that, and then we'll be ready to move on with the rest of the jump implementation. So we're going to make a function, and I'm going to call this function add debug indicator. I don't know, something like that. Okay, so this add debug indicator, I already kind of said what it needs to do, right? It needs to create an instance of, and an instance, right? If you drag a scene into the scene tree, that's a new instance. So you can have 3 instances of the same scene, for example. So we're going to create a new instance of this. So we'll define a variable to store reference to that instance. I'm just going to call the variable D, and we'll say it's of type node 2D. That's the root node of this scene, and that's sufficient. We don't need any special script on it. And this is going to be, this new variable D is going to be, we're going to type in that debug jump indicator, right? That's that constant scene reference that we created up here. And then it has a special function that we can call, and it's instantiate. And what that will do is it'll create a copy of that scene, and it's ready to put in our game. But just because it's been created doesn't mean it's in our game, in our scene. So we need to first get the tree, get the scene tree. And then we'll say add child, or I'm sorry, we need to say root. And then from the root, that's the root of our scene tree. Like if the root of our player would be this node, right? So what we're doing here is we're just getting our whole scene tree, finding the root, and then we're going to add a child. And then in here, we provide the child node that we want to add. And obviously that's going to be D. It's this new thing we just created. We're going to set a position for it. We need it to be positioned somewhere. Otherwise, it'll be defaulted to the 0, 0 origin coordinate. So we're going to say d.global position equals, and then we're just going to use the global position of our player. So this script is on our player. So wherever our player is, that global position, which is going to correspond with this little, this little cross at his feet, that's going to be the position we're going to get, and it's going to be global position, because if we look at our player, right, and look at all these nodes, like the transform of this is 0, 0, but globally it's going to be wherever our player is in the world. Okay, so then when we go back to our script, we're getting that position and we're using it to position this new object we've created. And then I do want to actually make it so that we can give this a color. Let's say d.modulate equals, and then we need to provide a color. Let's put an argument on our add debug indicator so that we can pass that in. So we're going to have a color of type color with a capital C, and I'm going to default it for now to color.red. Okay. So then we're just going to modulate this to that color, and because we made those textures white, they're just going to basically look whatever color we use to modulate it with. And we could just use this as is, but this is going to leave little indicators all over our screen, and they're going to just stay there forever. So I want to do one more thing, and I want to add an await. An await allows the code to wait for something to happen before it continues to execute the rest of its function. And so what we're going to wait for is we're going to say get tree, just like we did up above, but we're going to just call this function to create timer. So we're going to create a timer in our scene tree for, let's say, 3 seconds, and then .timeout. So what we're waiting is the timeout signal on this timer that we just created, which is going to time itself for 3 seconds. Once that's done, then we can just take D, this object, because we've stored a reference to it, and even though time will pass, we still will have a reference to it since we're still in this function. Then we can say d.queue free, like that. And that's going to tell the game engine, Godot, like, okay, time to delete this. It's going to remove it from the game. Okay. So there we go. This little debug indicator, let's go ahead and hook it into a couple spots of our code before we move on so that we can see what it's doing. So in our jump state, we'll want one whenever we enter. So as soon as we enter our jump state, we're going to call player.add debug indicator. And then the color we want is, let's just provide a color, color.green maybe. So whenever we jump, we'll do a green. Is there a better green than these in here? I mean, I guess fine. Oh, lime green. Look at that. That's a beautiful green. I'm going to copy this line of code. Now, the next time when we might want to add an indicator would be just before we leave this state and we're going to enter the fall state. So we could do that here in our code. We could also probably just do it in our exit. Okay, I'm going to make this one yellow. And then let's go over to our fall state. And I'm not going to do it on the exit of the fall state. I'm going to do it right here. I'm just going to show you we can do this multiple places, and this one will be red when we land, when we enter the idle state. Okay, so we should have some little indicators popping up now. Green, yellow, red. Nice. Now you'll notice we didn't get an indicator when we fell because we don't have one for entering the fall state. I guess we could have used entering the fall state to display that yellow indicator, and then that would have worked for falling. Oh, look at that. Do we already have a way to... Oh, we've got a bug, don't we? So interesting. You can see we're jumping clear down here. That's some major coyote time. But there we go. Now we've got indicators. That's that's going to help us debug what we're doing. Okay? So you can see jumping is green, falling is yellow, idling or landing is red. Okay, so that's going to just help us as we go forward. Okay, let's address this issue. It's not so much a bug, it's just a flaw in how we've implemented our state machine up to this point. So we could jump from here, but this little debugger here is key to noticing this. And some of you may have already noticed what the issue is, but when we walk off a ledge, you'll see that we're still in the run state. And we actually want to enter the fall state, don't we? So really what's happening is pretty straightforward because we haven't really hooked up the states properly. And if we look at our run, and in fact, we probably want to do this on idle too, but here in our run state, let's go down to the physics process and we need to do a check. And we're just going to say if player dot is on floor equals with 2 equal signs, right? For comparison equals false. If we're not on the floor, then we know we must have fallen. Okay. So we'll return fall state. Just to be safe, I'm going to copy this and I'm going to put it in my idle physics process as well. Like that. I'm thinking this could happen maybe if you had like a platform that suddenly gets disabled and you're in the idle state, then you need to fall, right? And so if you don't have a feature that does that in your game, then you don't have to worry about it. But chances are in the future, you'd add that feature like a platform that disappears or vanishes or crumbles. And then you'll be like, why am I floating? I'm still in the idle state until I move. You know, it might be confusing for a while. But there we go. Check if we're on the floor and make us enter the fall state. So now when we test this, now if I come up here, you can see I enter the fall state right away. And I can't jump from the fall state, okay? Wee, wee, wee. So much fun. Okay, we're finally ready to do this variable jump height. Now, there's a couple ways you could do a variable jump height. I think with the way we've implemented our code, there's a pretty simple way. So I'm going to come over here to jump. And really all we're going to do is we're going to come down to our handle input code in our jump script. And we're just going to listen to, you remember we looked at this before, but if we say if event, and it's an underscore right now. And by the way, someone had a really astute comment. I don't know if I mentioned this previously, but this underscore on an argument indicates that you don't intend to use the argument within the script. So once we do use it, I guess technically we probably should remove the underscore like this. Okay. The reason for this would be just to demonstrate this, if we don't have the underscore, then you see we get this yellow highlight and there's this little warning and it says the parameter event is never used in the function. And then it gives you this hint right here if this is intended prefix with an underscore. Okay. But so this is nice. If you're getting lots of warnings, that warning will print in your output as well, I think, or at least it used to. But I just like to add that underscore to remove that. So then once we're at this point, best practice would say that you remove this because now this communicates an intent to other readers of your code that you don't intend to use the variable, but now we are. So yeah, I guess we could do this. It's not going to break your code though, either way. The only thing the underscore does from a technical perspective in your code is prevent that warning. Okay. But then from a, like a code readability perspective or just communicating to other people, it does mean something. So we're going to say if event.is, sorry, that was a nice little tangent, right? If is action released, right? So if we release the jump button, this is what I want to do here. So we're jumping. If we release the jump button, then we know that, hey, the player wants to do a short jump. And actually the simplest way we can handle this is to just return the fall state. Now let's go ahead and test this out. Hey, is that working? It's not working. I mean, it kind of is. But the reason why it's not working great yet is because we still have our velocity. So just because we've entered the fall state, it's not actually changing our velocity. So you can see that it's entering fall early. Okay. So what we could do as an example is player.velocity.y. Let's just set it equal to 0. That's going to mean he's going to start falling from that point. Okay. Boink. That feels really abrupt, but it works. Okay. A thing that I like to do is to just multiply this. So instead of setting equals, we can do times equals, which is just shorthand for saying equals player velocity.y times, right? So we're going to say times equals, and then we can say 0.5. So it'll just cut it in half. We can try that. And this is going to feel a little bit better. Because if we do a really short jump, you can see he still kind of, boop, he pops up a little bit. But once we get up here, it's kind of like, oh yeah, we're just going to fall. Okay, so that's a good solution. And I think this is actually pretty sufficient. Now, in the future, I'm probably going to opt for moving this code to another location. But we're not going to do it right now. But the reason for that being is there's other spots in our code where we may want to implement this same kind of, velocity change whenever you release the jump button. Okay, but for now, this is good. So what we're doing is we're just decreasing our velocity before we return the fall state. And that gives us a variable height jump. And it's not physically accurate, right? But it looks okay. And it still honors our original jump velocity when we're holding down the jump button. Okay, so there we go. So we built our jump and fall states. We added some basic variable height jump as well as these indicators so that we can kind of troubleshoot and debug, and they're really going to come into play in the subsequent episode. In the next episode, what we're going to be doing is just adding a little bit extra. We're going to add coyote time, which is the ability for our player to jump slightly after they leave a ledge or walk off the edge of a platform, as well as a jump buffer so that there's a little bit of forgiveness when the player is kind of trying to jump as soon as they hit the ground, jump a second time. And we'll also do a little bit of tweaking to the jump and how it feels. So if you would like to, your homework assignment this time is to see if you can figure out how you might implement coyote time. So here's a quick tip. If you're going to try and solve coyote time, essentially what you need to do is you need to have a timer in your fall state so that you can walk off an edge and still be able to press jump for a split second afterwards and allow the player to jump. So that might be a little bit tricky on how to figure the ins and outs, but go ahead and do that. And then in the next video, I'll show you how I implement the feature as well as the jump buffer. So that's the episode. I'll be working on the next one. And as always, we'll see you next time.